Mesomeric Effect. I will teach you the super easy trick to solve all the important questions of Mesomeric Effect. Also, you will learn the complete topic of Mesomeric Effect. So watch this lecture till the end and you will learn something awesome. To learn Mesomeric Effect, you must learn the concept of resonance and resonance structures. Let's consider this organic compound. We can see that there is a double bond. We know that one is sigma bond and another is pi bond. Now there are pi electrons present in pi bond. Secondly, the positive charge on the third carbon means that it has a vacant orbital. Now listen carefully. There is possibility that these pi electrons will shift from first carbon to this vacant orbital. Now pi electrons are shifted from the first carbon to the third carbon. I mean, first carbon has donated pi electrons, so positive charge appears on it. On the other hand, the third carbon has gained pi electrons, its empty orbital has filled. Thus we define resonance as the possibility of shifting pi electrons is known as resonance. Let me repeat it. The possibility of shifting pi electrons is known as resonance. Here, in this molecule, pi electrons shifted, we say that resonance is happening here. Due to resonance, we get these two different structures of the same molecule. Thus, we define resonance structures as different structures formed due to resonance are called resonance structures. So, we say that these two structures are called as resonance structures are resonating structures. If you want to learn more about resonance structures, watch our lecture and its link is given in the description. Therefore, remember that resonance is the possibility of shifting pi electrons. Now let me teach you the basic concept of mesomeric effect. Well, we already know that resonance is the possibility of shifting pi electrons. Now I will use the analogy of resonance, which will make things super easy. For example, consider these two cases. In the first case, let these three brothers exchange football. I mean, the first brother gives the football to the second one and the second one gives football to the third one. Similarly, consider this organic compound. Here, the three carbons represent three brothers. We know that there is possibility of shifting pi electrons in the molecule, hence resonance occur here. Thus remember that three brother represents three carbons and the shifting of football represents the shifting of pi electrons. On the other hand, in the second case, there are two brothers and one sister. Let they also exchange football. Now consider this organic compound. These two carbons represent two brothers and this functional group represents sister. We can say that these are pi electrons which shift inside the molecule. Hence resonance occur in this molecule. Thus remember that these two brothers represent two carbons and this sister represents functional group, while the shifting of football represents the shifting of pi electrons. Now listen carefully. If resonance occur in two brothers and sister, it is also known as mesomeric effect. Let me repeat it. If resonance occur in two brothers and sister, it is also known as mesomeric effect. So this resonance is also known as mesomeric effect. Secondly, if resonance occur only in brothers, it is not a mesomeric effect. So here resonance occur, but it is not a mesomeric effect. Therefore remember that if resonance takes place in case of sister, this resonance is also known as mesomeric effect. That's why we say that mesomeric effect is the special case of resonance. Here, let me teach you one bonus concept. If I say every resonance is also known as mesomeric effect. Secondly, every mesomeric effect is also known as resonance. Can you guess that which statement is correct? Well, every mesomeric effect is also known as resonance. For example, here this is resonance but not a mesomeric effect, while there this is mesomeric effect as well as resonance. Thus note down all these important points. Now what is mesomeric effect? Well, let me quickly teach you conjugated system. A covalent compound which contains alternate single and double bond is called conjugated system. For example, consider this organic compound. Here there are alternate single and double bonds, so we call this system as conjugated system. Remember that for resonance we need conjugated system. Let me repeat it. For resonance we need conjugated system. Now we have already learned that for mesomeric effect, the first condition is resonance. The second condition is resonance having one sister. For example, consider these organic compounds. We can see that these two compounds contain alternate single and double bond, so they both are conjugated system and resonance is possible. In the first case, the oxygen and hydroxide has lone pair of electrons. Hence, this lone pair of electrons is shifted to this carbon, and these pi electrons will be shifted to this carbon. Here, electrons are shifted, hence resonance occur. Now listen carefully. This hydroxyl group donates electrons in the conjugated system through resonance. Let me repeat it. This hydroxyl group donates electrons in the conjugated system through resonance. In this compound, resonance occurs as well as mesomeric effect. On the other hand, in this case, there are pi electrons present in this double bond. While we also know that oxygen is highly electronegative atom. It means that the higher the electronegativity, the more it attracts the electron pair. So oxygen will attract these pi electrons and double bond is shifted in the system. Hence resonance occur as well as mesomeric effect. Now listen carefully. This aldehyde group withdraw electrons from the conjugated system through resonance. Let me repeat it. This aldehyde group withdraw electrons from the conjugated system through resonance. In this compound, resonance occur as well as mesomeric effect. Therefore, we define mesomeric effect as any functional group which donate or withdraw electrons in a conjugated system through resonance is known as mesomeric effect. For example, here the hydroxyl group donates electrons and resonance occur as well as mesomeric effect. Remember that this functional group is donating electrons. It is also known as positive M effect. While there, the aldehyde group withdraw the electrons and resonance occur as well as mesomeric effect. Remember that this functional group withdraw electrons. It is also known as negative M effect. Thus note it down that mesomeric effect is when a functional group withdraw or donate electrons through resonance. Now let me teach you mesomeric effect versus inductive effect. We know that electron pairs donating group is positive M effect. For example, functional group of NH2 has one lone pair of electrons. It can donate this lone pair of electrons through resonance, so it is known as positive M effect. Secondly, electron pairs withdrawing group is negative M effect. For example, aldehyde group like CHO withdraw electrons from conjugated system through resonance, so it is known as negative M effect. Now what about inductive effect? Well, consider this organic compound. We know that fluorine is a highly electronegative atom. It will attract shear pair of electrons towards itself. As a result of this, electronic cloud tilt more towards fluorine. Hence, partially negative charge appears on fluorine and partially positive charge appears on this group. This shifting of electronic cloud towards fluorine due to electronegativity is known as inductive effect. Here, this fluorine is known as electron withdrawing group and we represent it by negative I. While this is electron releasing group and we represent it by positive I. Thus remember that inductive effect is the shifting of electronic cloud towards more electronegative atom or group. If you want to learn more about inductive effect, watch our lecture and its link is given in the description. Now consider this organic compound. How can you determine mesomeric effect and inductive effect in this organic compound? Well, we know that there is possibility that this lone pair of this functional group can be donated in this conjugated system through resonance. This functional group donates pair of electrons. We call it positive M effect. Hence, this is mesomeric effect in this organic compound. On the other hand, we know that nitrogen is highly electronegative atom. It means that nitrogen attracts the shear pair of electrons. Now listen carefully. Due to mesomeric effect, this NH2 group donates pair of electrons, while due to inductive effect, this nitrogen of NH2 group attracts the shear pair of electrons. I mean, mesomeric effect is in this direction and inductive effect is in this direction. So there is a sort of fighting between mesomeric effect and inductive effect. Can you guess that who will win this fight? Well, mesomeric effect dominates the inductive effect and win this fight. Thus note it down that positive M effect is greater than inductive effect negative I. Also remember that there is one exceptional case in which negative I inductive effect is greater than positive M or mesomeric effect. It is halogen. For example, consider this organic compound. Here, this halogen or fluorine has lone pair of electrons. It can donate this lone pair of electrons in this conjugated system through resonance. Hence, it is positive M effect. On the other hand, fluorine is very highly electronegative atom. It very strongly attracts the shear pair of electrons. Thus, in this case, inductive effect negative I is more than positive M or mesomeric effect. Therefore, note down all these important points. Now let me teach you the super easy trick to identify positive M, negative M, positive I and negative I effect in any compound. Well, positive M effect shows those organic compounds which have lone pair of electrons, while negative M effect shows those organic compounds which have highly electronegative atoms like nitrogen, oxygen, fluorine, chlorine, etc. On the other hand, positive I effect shows those organic compounds which have alkyl groups, while negative I effect shows those organic compounds which have functional groups. For example, consider these organic compounds. In the first case, this OH group has lone pair of electrons. It will donate this lone pair of electrons through resonance. Also, we know that if lone pair of electrons is present in a group, it shows positive M effect. Secondly, oxygen is an electronegative atom. It attracts shear pair of electrons. Also, we know that if there is a functional group like OH, it shows negative I effect. Now, mesomeric effect donates lone pair of electrons in this direction and inductive effect pulls shared pair of electrons in opposite direction. We already know that mesomeric effect dominates the inductive effect. Here, positive M is greater than negative I. Thus, using this trick, we will answer all these questions. In the second case, there is no lone pair of electrons. It shows negative M effect. On the other hand, CN is a functional group. It shows negative I effect. Hence, there is negative M effect and a negative I effect in this organic compound. In the third case, it is just a benzene ring. There are 6 carbon atoms present in it, hence it doesn't show any mesomeric effect. In the fourth case, there is a lone pair of electrons on NH2. Here, it shows positive M effect. On the other hand, NH2 is a functional group. It shows negative I effect. We know that positive M effect is always greater than negative I effect. In the fifth case, there are lone pair of electrons present on fluorine. Hence, it shows positive M effect. On the other hand, fluorine is a functional group attached to a benzene ring. It shows negative I effect. Can you recall that which effect is more in this organic compound? Well, we learned that in case of halogen like fluorine-chlorine, negative I effect dominates positive M effect. It is because halogen like fluorine and chlorine are very highly electronegative atoms. They strongly attract share paired of electrons. In the sixth case, all the atoms are brothers. I mean, there is no sister. All atoms are carbon atoms, hence no mesomeric effect happens in it. In the seventh case, this NO2 has no lone pair of electrons, hence it shows negative M effect. On the other hand, NO2 is a functional group, it shows negative I effect. In the eighth case, there is a lone pair of electrons present with this group, hence it shows positive M effect. On the other hand, OCH3 is a functional group attached to a benzene ring. It shows negative I effect. We know that positive M effect is greater than negative I effect. In the ninth case, this functional group has a lone pair of electrons, hence it shows positive M effect. Secondly, this functional group attracts this share pair of electrons and it shows negative I effect. We know that positive M effect is greater than negative I effect. Lastly, it shows negative M effect. Also, there is a functional group. It shows negative I effect. Therefore, using this super easy trick, we can easily find positive M, positive I, and negative I effect in any organic compound. I hope that you have learned all about mesomeric effect.